So we had, as you can tell, a number of great applications in our finalists. Our top winner literally stood out above the rest and won the overall award in our Graphical Systems Design Achievement Awards. So here to talk about their application from Tsinghua University in Beijing, China, please welcome Mohan Xu and Yangfeng Gao. Good morning.
Good morning, Ray.
Good morning.
When our team decided to take part in the National VI Contest of China, we wanted to come up with a project that would be interesting, but also something we could actually finish in time for a project deadline. We looked at several options and finally found a project we were all excited about: 3D displays.
Our system uses 4 pieces of glass with optical film in an inverted pyramid configuration. A standard VGA projector reflects underneath the display, shines the images onto all 4 sides that bounce to your eye. So the light appears to coming from inside the pyramid. Well, the display is relatively simple. The real challenge is creating source images of 4 different perspectives of an object. The first method we created uses 3D models of an object. We used a LabVIEW 3D picture control to create a sphere and wrap it with a world map image. We can also load 3D files of standard format such as WRL. Once we set up the model, we just needed to create 4 picture controls on our front panel and set them to 4 different camera angles. Then we project our front panel onto the screen, and now you can see what the Earth looks like in this space.
Yeah. Displaying 3D models was really cool, but we wanted to be able to display real objects as well. In order to do this, we will need to capture many sides of an object. We decided to use a rotating platform controlled by our PXI 7340 and the NI Smart Camera to capture images. We had never used this hardware before, so we have to learn how to use the vision and motion components in LabVIEW. We used Vision Builder to create the basic code so we can record in a full rotation, then create looped clips that are timed so the viewing angle is offset by 19 degrees. Now we can display a real object or even an idea. Yeah. We finished this subsystem in just 3 days, and we even have time to add barcode recognition for any products on display.
Wow, is that amazing? So just to review, you've got 2 ways in which you can capture the images and display them. One is you use the files, and then you render them on the glass. And then second is you can use the smart camera and rotate the image and then produce it onto the screen.
Yeah, correct.
Well, actually, it was 3. In the end, we wanted to do live image capture. Since we were using iMac DX, we connected a USB hub and 4 off-the-shelf USB cameras. We mounted the cameras in this box at the proper dimensions for the display. And now we can display live images that appear to float in air. So let's see it. Can you see this? I put it in the box. And then run our program. Now you can see it there. Yeah, that's it.
Yeah. We use 3 different types of input with several very different types of procession and analysis method. In one system, we integrated modeling and parameter control for the software model mode, and synchronized vision and motion input with loop, and post-processing for the pre-capture mode, and finally, data streaming and image manipulations for live mode.
Well, don't forget our gesture control interface.
Just show it.
Okay, excuse me. We want to control our device, so we use another USB webcam and the vision assistant to build in recognition for some basic gestures. Now we can control things like the size of the image and the rotation speed. Let me show you. When I move my hands together, the image gets smaller. And when I move them apart, you can see it gets larger. And I can also use a one-hand gesture to control the rotation speed. Okay, it's too large. Okay. Now you can see it rotates with the motion of my hand. Thank you.
So you're thinking this is like a Ronco commercial, right? It's like, but wait, there's more, right? So in total, how long did it take you to put this application together?
Yeah, totally 3 months as we bring our idea from paper into this real system. Yeah. I think there is no way we would have been able to create so many subsystems in a short time span without using graphical system design. And since we were able to reuse the hardware from the past projects, we only spent $340 for all of the additional components.
You guys might want to think about delaying the purchase of those 3D televisions. They're going to have some new technology, probably by Christmas, that you might want to look into.
Yeah, this is low-cost system and easy to build. And it also brings a new approach to 3D displays that can open up many opportunities. 3D imaging would be valuable in medical applications, telecommunications, and even home entertainment. Yeah, maybe in the near future, we should be playing games based on this system together with advanced sensors.
That's great. So this is probably, as you could tell, just a perfect example of integrating all of the elements of modern engineering. Multiple models of computation, the display, multiple input devices is obviously why we picked it as our overall winner. Now, it's also worthy to note that when they competed in China in the VI contest, they took first out of 900 teams that competed in that event. So that truly remarkable accomplishment for what they've done. Now, it turns out that there are other contests that many of you are aware of that happen around the world. And we'd like to talk about some of the great success stories in those too. Dr. Trouchard mentioned the EcoCar team from Virginia Tech. They won the EcoCar Challenge this year. It's a 3-year program. They came in second. Last year, they came in first. This year, they're a poster child for graphical system design. I think they use every product that we make in the EcoCar. They beat 15 other teams and were a great testament to how teams that use our graphical system design tools are truly very competitive. Another competition that we're proud to be a part of is the Autonomous Robots Landmine Detection. This is a collaboration between the United Nations and our operations in Arabia. There are a number of teams from multiple countries, Qatar, Pakistan, Lebanon, that built robots that are being used to try to detect the landmines that exist in many of those countries over there. So as you can see, there are a lot of students all over the world, and we have many of them here in the building that were recognized this morning in the finalists and here on stage. And if you don't mind, if you guys that are here, stand up and let's give a big round of applause for all the students. Thank you. Thank you. It's great. Thank you very much.